Morning, children. The most important theorem from this chapter, the midpoint theorem. Theorem 8.9. The line segment joining the midpoint of two sides of the triangle is parallel to the third side and half of it. So, line segment joining the midpoints of two sides of the triangle. If you consider the triangle diagram, what are the sides AB, BC and AC? Only two sides midpoint only we have to join. So let us take E is the midpoint of AB and F is the midpoint of AC, right? So we have joined that line. If this is the line joined by the midpoints, then what is the condition? The line segment joining the midpoints, that means EF is the line segment joining by the two midpoints of the sides of the triangle. So what is this one? EF is parallel to BC and half of the BC, right? So once again I will tell what is the concept of the meaning of the statement. The line segment EF joining the midpoints of the two sides of the triangle. That means E is a midpoint of AB, F is a midpoint of AC. Is parallel to, that means EF is parallel to the third side, which is not considered now. We have considered only AB and AC for the midpoint. So BC we are not at all considered. So that means it is parallel to third side. So EF is parallel to BC and also EF is half of BC. That we have to prove. So for this, what is given in the question to be written first? What is given in the question? Triangle ABC is given. Okay, E and F are the midpoint. Then can we write AE equal to EB? And similarly AF equal to FC. So I'll mark this equal sign by this. It is a midpoint, so it divided equally. So the second equal side, that is AF and FC. Got now? So now what is the next one? We have to prove that. To prove the midpoint joining. So E and F we decided the midpoint. The line segment is joined by the midpoint. That means EF parallel to BC and EF equal to half BC. This we must prove. Okay. Construction. What is the construction here? We have to draw a parallel line to parallel line CM with the BA. So draw CM parallel to BA. So BA is this side. So with the same side we are using and we are drawing the parallel line now. So I am drawing a parallel line CM here. To which side of the triangle BA? CM is parallel to BA. This is the construction. Still it is not completed. EF to be extended to meet CM at D. So I am extending EF to D. So here I will mark D. Right? So this is the construction we have taken. So I will write here, draw CM parallel to BA. Okay. Extend EF to D to meet EF at CM. Okay, so EF is meeting at CM at D only. Okay. Now we have to go for the proof. What is the proof means? What we require to prove? This line is parallel. EF is parallel to BC and also it is equal to half of BC. So for this, what we are considering, these two opposite triangles. Which are the triangle? Triangle AEF and triangle CFT. So I'll take this way. In triangle triangle AEF and triangle CFD. right? So what are the equal things we can write here? AEF and CFD if we are writing, already we marked equal side is which one? AF and FC. So I can write here AF equal to FC. The first equal side we got. Now what about angle F and here angle F? What we can say? Vertically opposite angles. So angle F equal to angle F. Vertically opposite angle. Here what we should write? F is the midpoint, we can write midpoint of AC. And again the second criteria is vertically opposite angles. Now we got one angle and one side. Now listen, we have made the parallel line. So I have marked the CM parallel sign here. Here also I should mark parallel because we have drawn CM parallel to BA only. So these two lines are parallel. So if this is the transversal, can we write angle A equal to angle C? What is the idea behind this angle A and angle C are equal? That is alternate interior angles are equal. So what is the reason I should write alternate interior angles? So triangle AEF is congruent to, what is order for A? It is C. What is order for F? It is also F only. So what is left now? The letter is in middle only, CDF. The criteria is ASA. If you check this, S is the included side. So now we got triangle AEF congruent to triangle CDF. We have used only one side, which is that side AF and FC. So what is the remaining side? AE I can take. So AE equal to CD, CPCT. One more side is there, which is that one, EF equal to FD. EF equal to DF. The order is DF. So CPCT here also CPCT. So I'll make it equation number 1 and equation number 2. Okay, now we got AE equal to CD, EF equal to DF by CPCT. If AE equal to CD, can we say that BE is also equal to CD? Yes or no? Because AE and BE are equal. Because E is the midpoint. Remember that point? E is the midpoint. So in one we got AE equal to CD. Right? But AE is also equal to B. Therefore, B equal to CD. Equation number 3. Now, we can also say that BE parallel to CM. Okay, right. What is the reason BE parallel to CM? BE parallel to CM means we have by the construction. What is the reason for this one? Construction. That is the then what we can say? BE parallel to CD. Equation number 4. After seeing 3 and 4, what is the idea you are getting? One pair of opposite side is equal and also parallel. So we will write one pair of opposite side is equal and parallel. Therefore, BCDE is a parallelogram. BCDE is a parallelogram. We got here B parallel to CD, B equal to CD. Now we got that BCDE is a parallelogram. So which is the not mentioned side? BC and ED. So this implies BC parallel to D and BC equal to D. If BC parallel to D, so we can write EF is a part of D only. So BC is parallel to EF, right? Now BC equal to D. BC equal to DE, we can split DE in terms of EF plus FT. But in CPCT2, EF and DF are both equal. So I can write here EF plus EF using 2. So it is equal to 2EF. So what is EF now? EF equal to half BC. So what is the conclusion we got from here? EF is parallel to BC, EF equal to half BC. Hence proved. So when we are joining the midpoints of the two sides of the triangle, that line segment is parallel to BC and equal to half of the BC. So what we have taken, we have drawn a construction that CM parallel to BA. We have marked first E midpoint concept. So E is a midpoint, the first equal side. F is a midpoint, second equal side. Now the parallel sign also we have marked. Now the opposite triangle we have taken for the congruency. So triangle AEF congruent to triangle. What is order? CDF by ASA criteria. The first angle is F, vertically opposite angle. A and C are the alternate interior angle. Then AF equal to FC, that is the midpoint property. So we got triangle AF congruent to triangle CDF ASA. By this 2 CPCT we can write what it is. AE equal to CD and EF equal to DF. Now AE equal to CD. But we know that AE and BE are also equal by the midpoint. So when AE equal to CD, BE is also equal to CD. So we got BE equal to CD. Again, how we can write the parallel concept? BA parallel to CM, right? So BE is also parallel to CD. It's both are part of it. So we got BE parallel to CD. Again, what is the concept here? One pair of opposite side is equal and parallel. So BCD is a parallelogram. If it is a parallelogram, other pair of opposite side is equal and parallel. That means BC parallel to DE, BC equal to DE. If BC parallel to DE, directly we can write BC parallel to EF because EF is a part of DE. Now DE means what? From the figure, if you know, that means EF plus FD. EF and FD are equal in CPCT2. So these two can become 2EF. So EF equal to half of BC. So hence proved. So what we learned from the midpoint theorem, when D and E, if let me take the triangle nu 1 PQR, D and E are the midpoints. Then what is the concept we learned? D parallel to QR and DE equal to half of QR. That means if QR is suppose 6 centimeter, then what is the length of DE? DE equal to 3 centimeter. Again, if I draw another line like this, EF is the another midpoint, F is the midpoint here. So EF will be parallel to PQ. If these two are the midpoints, so what is the concept now? EF is parallel to PQ and EF equal to, EF is parallel to PQ and EF equal to half PQ. So what is the concept now? Suppose PQ equal to 8. So what is the length of EF? It will be 4 centimeter by midpoint theorem. Another one, I join DF. D is the midpoint which side? PQ. And F is the midpoint of QR. So what is the concept here? DF will be parallel to, DF is parallel to the third side PR and DF equal to half PR. Got? So suppose I am taking that PR equal to 7 centimeter. PR equal to 7 centimeter. So what you can say about DF? DF will be 3.5. Right? Similarly, DF is also parallel to PR. So I think you got the idea. That means when DF length is given 3, you can calculate QR length. Because if this is the midpoints. So if it is 3, it will be double, that is 6. If it is 3.5, then the base will be 7 centimeter. If it is 4, then it will be 8. What is the rule says? The line segment joining the midpoints of the two sides of the triangle is parallel to the third side and half of it. I think the idea is clear to you. So when we are given the, suppose the length is, suppose here 10. So what will be the length for D? It will be 5. Right? Like that, when it is given the full length of a base, you can calculate the midpoints line segment also. So this is the idea we got from the midpoint theorem, one of the important theorem. You should practice, because here little bit construction also is coming. Based on that we are doing the proof. So practice, and the question can be asked in this way, that state and prove midpoint theorem. So statement also you have to learn by heart, right? So with this, today's class I'm winding up. Thank you.